Hello and welcome to part 2 of the solar installation series. I'm Beth. I'm an ABYC Marine Tech. I teach workshops for National Women's Sailing Association and also usually once or twice a year a weekend workshop for women on marine systems, currently at IRIS, that's IYRS in Newport, Rhode Island. I hope that I can do one of these this fall, but this is 2020. We're in the middle of the pandemic, so I don't really know yet whether that class will be held in 2020. And I'm going to be explaining different components that I'm using putting together this solar panel installation and what the different parts do and how they fit together. Okay, let's go through the components of the system. This system, the first thing I have is a solar panel. This one's a 50-watt solar panel. It's actually meant for shoreside use. But I'm going to prop it up in the cockpit of my smaller sailboat that's going to be on a mooring this summer. These are the cables I'm going to use. They're called MC4 connectors. They're pretty standard solar panel connectors. They're nice and waterproof, and this panel actually is pre-wired with them on the back of the panel. So my installation is going to be easy from that standpoint, because I can just clip those in. Now, these come with a male and a female, one wire to each end. I buy them pre-wired. You can theoretically buy flat cable, put your own connectors on, but I've done, 3 of these in the last 3 years, and I know with all electrical connections, you need to practice to be good at it. This is something I want to put up on my coach roof and never look at again. So I want to buy the ones that are pre-made. That's my decision. You might do something different. One trick I learned from somebody, and I think I've got 2 panels actually, so I bought twice the length I needed of cable, and I'm going to cut this in half. I'll use 1/2 on this installation, and then when I come to do the other one, because of the way these things are put on here, I'm going to have to use the red one on the negative and the black one on the positive in that case. And in that case, I will label, so that it's clear to anyone else, to me, when I forget later, and anyone else looking at the system, what I did and what the wires really are connecting. So that's an important thing if you do that. It does save you some money, though, because you can buy a set of longer ones for a lot less than buying 2 of the exact length you need. These cables are going to go from my panel, and I have the positive cable. I'm taking it to this switch here. This is actually a circuit breaker. This is a 25 amp circuit breaker. I'm not going to put anything near 25 amps through this, but that just means that it's heavy duty and it's not going to put too much resistance in my circuit. Anytime you put a switch or anything in a circuit, you add resistance, and we're trying to get as much out of these panels as we can. So I want to limit the resistance, but I like having this. This is something that not everybody puts in their solar panel installation. It's an extra safety feature that I like to have, and the reason I like to have it is if I have any problems with my controller here, and I don't want to cover my panels or worry about the fact that the panel's sending down electricity that might conceivably shock me or someone else that's working on the system, I have this in here so that I can just break the circuit and then work on this, and I don't have to worry about this. So hopefully I never ever need this switch, that this always works forever, but it's here just in case of that. And that's just, as I said, not everybody does this, but that's something that I like to have in my system. So from this circuit breaker, the positive wire is going to go into my MPPT controller, and from my controller, it will go into this fuse, and the fuse from there to the battery. Now, the negative wire comes down and goes into the solar panel MPPT controller, and then from the controller that goes straight to the battery or to a bus bar, whatever, that hooks up into the battery. This fuse is required by ABYC. This is a charging source. All charging sources into the batteries need to be fused. You need to fuse them close to the battery. If you put some kind of conduit around the cable, then you can get away with 40 inches away from the battery. If you can't put a cable there, then this fuse needs to be within 7 inches of the battery. You want to limit the run from here to the battery anyway, so this fuse placement is something you have to consider when you're looking at where you're going to put this, where you're going to put this. It's nice to put these fairly close to the battery. This thing knows what temperature it is where it is, so if it's in the same battery compartment, it can adjust its charging according to the temperature, and it will be accurate to where the battery is. You don't want to place it right on top of the battery unless the battery's got some kind of protective cover on it, but nearby is really good. Now, I don't work for anybody who has any of these different brands. I just like these brands, and I like this Victron one especially because it's a smart solar charge controller. It's not too expensive. It's like 129 bucks maybe, and it has built-in Bluetooth and an app. So in part 3, when we hook everything up, we can actually look on my iPad and look on the screen and see what this is putting out at any given time. It also gives you history of the last 30 days of output and detail, and then it keeps a running total of your ever since it was hooked up. So that's pretty cool. Alright, well that concludes part 2 of the solar installation series. I hope you found that useful. Stay tuned for part 3.